Hello children, warm welcome to the Chemistry Content Library for Grade 10. This is a module-based presentation on a workbook. Let me start with one of the most important tools for a chemist, a tool that is inevitable. I think some of you must have guessed it. I want you to brainstorm on the most important thing that a chemist uses. I hope you have guessed it correct. It's nothing else other than the periodic table of elements. This table is equivalent as numbers in mathematics. Everything around us, including ourselves, are a combination of the elements that we see on this unique table. In one glance, you can see the elements that make up nature's entire collection of chemical substances and how these elements relate to one another. Let's look at the objectives of this module. Here is the first page on this module. Objectives and guidelines to be followed are given here. Read them carefully. Let's start with something fun. As you see here, there are some words and a sentence. On the first image, it says, I heard that oxygen and magnesium were going out and I was like, oh my God. Next image is written, teacher. Then we have father and the last one says, inspire. So all these words are created from the symbols that you see on the periodic table, symbols of elements. So as the first task, I want you to create some meaningful words or even sentences using the symbols as it is. This mighty table that hangs in every chemical laboratory is the consequence of organizing the knowledge gained by a number of scientists through their observations and experiments. In 1800, a German chemist, Johann Dobrinier, was the first to consider the idea of trends among the properties of elements. He saw that there are groups consisting of three elements that have similar chemical and physical properties. In every group, the atomic weight of the middle element was half of the sum of the atomic weight of the other two elements. Properties of the middle element were also in the halfway of both the elements. Dobrinier called this grouping method as the law of triads. Later on, it was found that this law was not true for every element and hence it was not successful. Now let's look at Newlands Octaves. In 1865, after the failure of Dobrinier's triad, the English chemist John Alexander Newlands gave the law of octaves. According to him, elements can be arranged in ascending order of their atomic weights. He also said that in this arrangement, every eighth element of a row had similar properties to that of the first element of the same row, depicting the octaves of music. This law was also dismissed as it was only true for elements of up to calcium. On February 17, 1869, a Russian professor of chemistry, Dmitry Mendeleev, completed the first of his numerous periodic charts. It included 63 elements arranged according to increasing atomic weight. The real development in the table took place after the development of Mendeleev's periodic table. He proposed a law which states that the properties of elements are a periodic function of their atomic masses. He arranged elements in periods, that is horizontal rows, and groups, that is vertical columns, in the increasing order of atomic weights. The vertical column consists of elements that have similar properties. The first session on this module ends here. Link of the workbook is given in the description. Read it thoroughly and complete the task on today's topic. Meet you soon in the second session of this module. Thank you, children.